Hello and welcome to the screencast on polynomial regression in MATLAB. In this screencast, we're going to learn how MATLAB handles polynomials, about the POLYVAL command, the POLYFIT command, and then how to plot a polynomial trend line on top of a scatter plot using only the command window or an M file. So first of all, just to review, in mathematics, a polynomial is a function that is a combination of power functions with coefficients multiplied in front of them. That's in mathematics terms. In MATLAB, we have a special way of representing them. We represent polynomials as vectors containing the coefficients, where the first entry is the leading coefficient. For example, the polynomial above would be represented by this vector. There's a 0 there because there is no x to the fourth term. Now, the command polyval is used in MATLAB to basically plug a number into a polynomial. In mathematics terms, we would simply replace the x with the number we wanted to plug in. In MATLAB, if I had this as my polynomial to quote-unquote plug in 4, I would use the command polyval. And polyval, parenthesis p comma 4, takes 4 and plugs it into the polynomial p listed above. So in other words, polynomials for MATLAB are a certain kind of data type and more than just a function. Let's play around with this some more here in the MATLAB command window. I'm going to define p to be the polynomial 2, 1, negative 1. That would be, in math terms, the polynomial 2x squared plus x minus 1. Let's go ahead and leave it like that. Now if I wanted to plug 10 into this polynomial, I would type polyval p comma 10. And I should get 209, which is what you would get if you did it in mathematics. Now the nice thing about polyval is that it's vectorized. That means I can also plug in a list of numbers and have it evaluate all at the same time. For example, polyval p, and if I wanted to plug in not just the number 10, but let's say all positive integers from 1 through 10, I could type 1, 1, 10, and it would evaluate all 10 of those numbers automatically at the same time. And this is very important when it comes to plotting. One of the reasons MATLAB has special functionality for polynomials specifically is because polynomials are very useful and simple models for data. As we saw in the basic fitting tool screencast, polynomials often make very good trend lines to give us lines of best fit or curves of best fit through data. And speaking of data, I have a variable over here in my workplace called JOCO population. Let's double click to open. And what this variable contains are 2 lines of data. This is like a mini spreadsheet. In the first column are year values, and in the second column are population values. Let me say a few things about how I've scaled the data here. The years here are years since the year 1830. So when you see 0, that's the year 1830. This is the year 1840, 1850, and so on, all the way down through the year 2010. And in the second column is the population of Johnson County, Indiana, where I'm currently located, in thousands of people. So in 1830, there were 4,019 people in Johnson County. In 1930, there were 21,706 people, and so on. I'm going to close that out right now. And what I'd like to do is look at a scatter plot of these data just to get a sense of the overall trend. And I have an M file open right here that will create such a scatter plot. Just to walk quickly through the code and what it does. The first line here, close all, simply closes all open graphics windows when I execute. The second line takes the first column of the JOCO population variable, that's got the years in it, and just calls it year. This third line takes the second column of JOCO population and assigns it to the variable pop, and the rest of the stuff is just trappings that will make the plot look nice. And here's the plot that we get. So one of the things I would like to do with a scatter plot like this is to put a line of best fit through it. The data don't look linear, but it's a good start for fitting the data just to create a simple line. Now I could do that with the basic fitting tool, but I can actually do that from the command line or from an M file. Let's go to the command line for a second. Now there is a command in MATLAB called POLYFIT. POLYFIT. And let me just type in the syntax that I will use. POLYFIT year pop and then 1. Let me explain what each of these arguments means. POLYFIT is going to create a polynomial regression line of best fit. The first argument is the x variable in my data. The second argument is the y variable in my data, and the third argument is the degree of the polynomial I want. By putting in degree 1, I am specifying a line, a linear function of best fit. If I wanted a cubic of best fit, I would change that to a 3, for example. And when I execute polyfit, it will give me back a polynomial. This, as a function, is the function y equals 0.5807x minus 12.5513. I'm going to re-execute that command one more time, except I'm going to store the output as a variable. So P is equal to polyfit. And again, the syntax for polyfit is entering your X data here, your Y data here, and the degree you want. And there's P again. Now I can do some fairly interesting things just right here. For example, if I wanted to get a prediction from this linear model of what the Census Bureau would say about the population in the year 2020, that for me is the X value of 190, that would be plugging a number into this polynomial. So I would use POLYVAL P190, and it would predict a population of about 98,000 people, 97,788 people. Now what I would like to do is maybe to plot this line of best fit right on top of the scatter plot. To do that, I'm going to have to do a few things first. I'm going to define PP equal to polyval P, and here I'm not going to plug in a single value for my time. I'm going to plug in the entire year vector. A little earlier we saw that polyval is vectorized, and if I wanted to evaluate a polynomial and a whole string of numbers, I could do that. And so when I enter in this, it's going to be a lot of numbers, but these are the year values, these are the population values that my linear model would predict for all the years that I have in front of me, from 0 to 180. Now that's a vector, and I can plot that like any other vector. So I have already my scatter plot over here. I'm going to superimpose a new plot on top of it, so I'm going to type hold on to make sure I don't wipe out my current plot. And then I'm going to plot, using the plot command, the data that I just came up with. And to do that, remember, I have to have the X variable first, that's year, and then my Y variable, which is PP, and I'm going to format this so it's a solid red line going through the data. And once we click back over to the scatter plot, I see there's my line of best fit. Again, not the greatest fit, but it is the best fit that a line can possibly get. Now I'm going to go and add all those commands to my M file here, just because it seems like something I'd want to do over and over and over again. So I'm going to add some space here and just type in the commands we saw a minute ago. P was equal to polyfit year population with degree 1. And then I assigned to PP the values of polyval P at all the year values. Basically, I'm plugging in all those year values to P all at once. And then I had hold on, and then I would type plot X variable first, year, PP, for Y variable, and then I formatted it with this. Now, run this again, and it should give me the same plot as before. There we go. Now what's nice about this is I can go in an M file, I can control a lot of things. I could change this, what if I wanted a cubic instead? Well, all I would have to do is change this 1 to a 3. Now let's again review what's going to happen here once I click the execute button. It's going to plot the scatter plot and label it like it had before. P is going to be the cubic polynomial, the degree 3 polynomial of best fit through my data. I'm going to take all my year values and plug them into P. Just as when we were creating a basic mathematical plot using the plot command much earlier in this series of screencasts, we had to enter in the create a variable for x's and then create a variable for the y values. That's what we're doing here through the polyval command. We're creating a vector of y values. Tell the graph to not overwrite and then plot it. And now we run the M file, and I see a very nice plot here. Here's the red line, the cubic that goes up through. The one last thing I might want to do is add that cubic to my legend, and I'm going to have to do that manually just by adding a second string argument here. We could just call this the third degree polynomial, like so. Rerun that M file, and there we have the scatter plot, the cubic, and it's labeled in the legend as we would like it to be. So let's recap what we learned in this screencast. We learned that polynomials in MATLAB are actually a data type. We represent them as vectors containing the coefficients. We've learned about the polyval command, which allows me to plug single numbers or entire vectors worth of numbers into a polynomial. And we've learned about the polyfit command, which generates the nth degree polynomial of best fit to a set of paired data. And if I'd like to plot a polynomial of best fit alongside or on top of a scatter plot of paired data, I can follow this little procedure here. First of all, generate the nth degree polynomial using polyfit, plug all your x values into that polynomial using polyval, and then plot the result, basically just like you would any other mathematical plot, by typing hold on so as not to overwrite the scatter plot, and then just plain plot. That's all. Thanks for watching.